Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss one very interesting AWS setup widely used by many companies nowadays, especially for processing or analyzing their big data. Okay, and the architecture looks like this. So what it is indicating, let me explain. Okay. So here this is our DataLake, which is S3, where processed data or raw data in CSV or Parquet, ORC, Avro in different file formats it is stored. Okay. Now there are some members from data analysis or marketing analysis related background who need to run ad hoc queries for analyzing the data. Okay. And there are some members from data engineering team who need to run heavy ETL jobs on the DataLake data. Okay. So now the question comes, is there any possibility that for both data analyst as well as data engineering team, we can create a single table? And the answer is yes. How we can do that? That is basically using Glue Data Catalog. Using Glue Catalog, if we create a table, that particular table can be used by the data analyst or marketing analyst team. They can directly execute ad hoc queries from Athena, right? And if data engineering team want to read the data, which is basically pointing to some S3 location from the Glue Catalog table, what they can do, they can read the catalog table in Spark directly. And like how we read the Hive table in Spark, that is spark.sql, let's start from this table. Like the same way they can execute this query in Glue Catalog. They can read the table data in a data frame. They can do all kind of processing. Okay. So that is nothing but power of Glue Catalog, which is acting like centralized metadata storage. Okay. And that's what I am going to show you in this video. Already in my previous video, I have discussed that how you can use Glue Catalog as external Hive metastore. That is in EMR in Hive, if you create some table or anything if you do, then that metadata for those tables will be stored in Glue Catalog, right? So that way, if the EMR goes down, then if you are spinning up a new EMR cluster, in that EMR cluster also from Hive, you can basically use the Glue Catalog to regenerate those tables and all, right? But suppose you are using EMR's local metastore, then obviously if the EMR goes down, you cannot access the tables, right? So that is another advantage of external metastore. Okay. So I hope you got the point. That is, here in Glue Catalog, we'll be creating a table. And if we do that way, then obviously the data analyst team also can access the table from Athena. And let's try to understand how we can integrate Glue Catalog with EMR Spark. Okay. So that we can read the data in Spark from Glue Catalog directly. Okay. So here you can see I am referring this particular document. Use the AWS Glue Data Catalog as metastore for Spark SQL, right? So why here Spark SQL is written, you can easily understand. Because Glue Catalog is nothing but what? Database table structure. Now when you are using Spark to read the data from Glue Catalog, obviously you have to use Spark SQL. Like we read the Hive data, Hive table in Spark, right? How we read Hive table? That is spark.sql, select star from this Hive table, right? Database name dot table name will put. Like that same way, we can basically read the Glue Catalog table from Spark using Spark SQL. So that's what is written here. Okay. So here you can go through this document in detail. I will not go through that, but rather what I will do, I will quickly go to AWS Management Console, and here I will go to EMR and launch a new EMR cluster because that might take some time. Okay. Before that, I will just go to AWS Management Console, and here I will go to EC2, and then here I will create a key pair. Okay, for testing. Create key pair, demo Glue Spark. This PPK file I am downloading. Create key pair. Okay, that is done. And now here I'll go to create cluster. I'll go to advanced option. Okay, queue not required, pig not required, only Spark, Hive, etc. I'll be keeping. Right. Then a very important point here, AWS Glue Catalog setting. So whatever tables in Spark will be creating using Spark SQL. Okay, those things we want to store in Glue Catalog. So I will check this one, use for Spark table metadata. Okay. Then here external configuration we need to put. So if you see this documentation here, this particular external configuration is written. I will just copy that and paste it here. Okay. And that's pretty much it. I will go to next. So this is just a demo, right? So for this example, let's keep master this extra only, but code I can reduce. So maybe C1 medium I can keep, just too small, and I will save this one. 2 instance is fine, so that I can show you that in parallel processing also it is working, because core 2 means more than one worker node, right? Okay, so then what we'll do, we'll go to next, right? And here I can give the name Glue Spark Integration. Okay, like that name I'm giving, and then here I'll go to next. What's this one? Right, and here I will be selecting my EC2 keep here, and then here what I will do, I will basically create the cluster. Okay, so here it is going to take some amount of time. Till then what we can do, we can basically go to Glue and we can do all the setup and make it ready. Okay, so first I will go to S3, and here I will be creating a bucket first. So create bucket, demo Glue Spark from EMR. Okay, this name I'm giving, and then here I will create the bucket. So this is the one, right? And here I will create the folder. The folder name can be CSV data raw, some name I'm giving. So first I will upload a CSV file here, and what I will do, I will run a glue crawler. Okay, and crawler will crawl the data, and obviously will create a table in our glue catalog, right? That table we will try to access in Spark from EMR cluster. Okay, that's what we are going to do. So you can see the data very simple. ID is basically integer column, sepal then sepal with petal then petal with, all are double type, and class name is basically string type or varchar type, right? So here what I will do, I will upload this data quickly. I will just select that one and I will upload. Okay, right? So it is uploaded, and as the next step what I will do, I will go to Glue. So here I'll go to Glue, and then here I will go to database. So currently nothing is there, that's fine. I will go to crawler and I will add crawler name demo white, simple name I am keeping. I will go to next, and then here S3 path, right? So here I'll go to properties section, I'll copy this S3, I'll paste that, right? And then here I'll go to next. So here I am using an existing IAM role which is having Glue service role. That's it, just with S3 access, so that it can have permission to crawl the data. I'll go to next, run on demand, that's fine. Add database. Okay, so here I can give EMR Spark Glue table. This is my database name. I will just save it in my notepad, right? And here I'll create that. Okay, it's created, and then here I'll go to next. I will click on finish. Okay, so here it is done. Now what I will do, I will just click on run crawler. Okay, I will create a table in our this particular database. If I just refresh this one, here this is the database, right? Currently no table is there. So if we run the crawler, it will crawl the CSV data what we have uploaded, because you can see here it is pointing to that particular location only, and then it will populate a table in our Glue Data Catalog. Okay, so here we will click on run crawler. So here it is started, it's fine. I will go to EMR, and it is still in starting phase. If I go here, you can see it will take some time, so we have to wait a little bit. And till then, let me show you this Spark code what I am going to execute. Okay, in EMR cluster. So from Spark PySpark.sql import Spark session, which is the common stuff. Then from Spark SQL function, we are inputting everything. We are creating this Spark session. We are using builder. We are giving this app name. You can give anything. And we are using get or create. If it is existing, we will use that. If it is not existing, it will create that. Okay. Then here we can execute show databases. If we do show databases, what should happen? It will basically list down all the databases present in our Glue Data Catalog. Because here in Spark, in the configuration we have mentioned that Spark will SQL the Glue Data Catalog for metastore. Okay. Then here we can basically read the table, also select start from the table whatever our crawler will create in our catalog, and then we are doing df.show and we are executing some more steps. I will come to that, but let's see EMR first spin up. So this starting, let me see the crawler state. So here you can see 1 minute elapsed, so stopping. So that means table is created. If I go here and if I go to tables, here see CSV data raw, this particular table is created pointing to this particular S3 location. That is kind of, it is external table only, right? So here you can see it has basically tried to invert this schema. ID is begin, as you can see ID is integer column, then sepal and sepal, petal and petal at double type. Here also it has invert that way only, and class name is string. So here you can see class name is string. Okay. Now once this Glue catalog table is created, suppose there are data analyst or marketing analyst, they can simply open Athena and start querying this particular table. Okay, I will show you. So I will go to Athena, and then here I have chosen Glue Data Catalog. So database name I will just replace. So this is EMR Spark Glue Demo, that is our database name, whatever we are having. As you can see, EMR Spark Glue Demo. And then here tables, this is the table, right? So I can just do select star from CSV data raw limit 5. If I just do that, and if I just run here, the data analyst or marketing analyst can see the data. Okay, that is fine. But now the question comes, how the data engineers can access the data? Because in Spark, they want to access the data and then apply transformation, right? So for that, we have to wait until this particular EMR is ready. See, waiting cluster ready. Now here what we will do, we will go to this place. I will just copy the master public DNS, and then here I will try to enter in this particular EMR using SSH. Okay, I have already downloaded the PPK file. We'll just open that. Okay, it is taking some time. Let's see. Network error, connection timeout. Okay, fine. So basically what happened, we have not allowed to do SSH in the master node. So I will just click on this security group, and then here I will go to master security group, and then here we have to add the inbound rule, right? So here I will go to add rule. As of now I am keeping all TCP, all IPv4. I'll just save it. Okay, right. Now we will try to do the same thing. See, now it is coming. Login as Hadoop is the default user ID, as you know. And here we have entered in the EMR. I will just change the setting so that it will not have timeout issue. Right. And now here what we'll do, without any further delay, we will enter into PySpark. Okay. And we'll start executing all the queries one by one. So we have seen that the data analyst or marketing analyst team can access the data using Athena, and they can do all kind of stuff for analyzing the data, joins and all, ad hoc joins kind of stuff. And now suppose data engineering team is there who want to read the data from the table and then want to process that. Then what we have to do, let's see. So I just copy these two ports. And here we have entered in the Spark. I will just run these two simple imports, and then here I will create the Spark session. Right. Now here what I will do, I will basically execute show databases. Let's see whether it can list all the databases from Glue or not. Okay, I will just hit enter. And see, database name one is default, which is by default generated. Another one is EMR Spark Glue Demo. That is basically here in the Glue. This is the database, right? If I refresh here, default will be also there. So see, default Hive database is there and EMR Spark Glue Demo, right? So both the database it is listing, right? It is perfect. Now what we want to do, we want to read the data in Spark from Glue catalog, right? So this is the database where our table is present. So I will just paste that one, and basically database name dot table name we have to give, right? So I will just take the table name, whatever our crawler has created. So I will just do this one, tf equal to spark.sql We are reading the data and it is done. Now let's do df.show to just have a primary glance in the data. Okay, and if you see the data, here you can see this is what it is giving. Okay, that is basically it is able to perfectly read the data. But there is one small problem. As you can see, the first row is trying to take null, and class name is coming as class name. Why it is happening? Let me explain. So basically, whatever column name is there, that one it is trying to put in the first row. Okay, this is a kind of strange behavior you can consider while working with Glue Catalog and Spark. Okay, so ID is basically string type, right? But this column is actually integer. That's what in Glue Catalog also it is set it. Now when ID, this particular one, it will try to cast to integer, then it will be having null value because ID is a string. It cannot be casted to integer, right? So for all these 5 columns, we are getting null value in the first row because they are either integer or double type column, and here the Spark is trying to take the column name in the first line only, and it is basically casting to null. But the class name is string type, na? Now what is happening that the class name is easily coming here. So this is just kind of cleaning we have to do. So that is very easy step. What I can do in this case, I know that in this particular data ID column cannot be null because that is primary key. So I can just filter on ID column, that if ID column is not null, that data only the clean data. Okay, so I will just read that right in df1. Now if I do df1.show, here you will see that we are able to perfectly get the actual data. Whatever our data analyst was getting, that same kind of data engineers also will be getting. Okay, and this is how the Glue Catalog is basically acting like a centralized location for accessing the data from a table for both the data analyst or marketing analyst as well as data engineers, right? And even if I do df1 dot print schema, here you will see the ID column is long, sepal length, petal with a double type, class name is string type, which is perfect, right? Now maybe let's do some transformation, a very simple transformation I am doing as of now. Just we are doing group by on class name. As you know that in ID's dataset there are 3 different categories of class. One is ID Sedusa, one is ID Spargenica, one is ID Sparsicolor. So we are just doing group by on that. Okay, and we are just taking sum of sepal length, and here we are giving the column name as sum sepal. Okay, and then here we can basically store the data in df2. If I just do df2 dot, let me just make it little upper. Here I will do df2 dot show. Here you will be able to see the group data set. Okay, now here we have seen that both from Athena as well as from Spark we are able to read the Glue Catalog table. Okay, now comes writing, right? It might happen that after processing the data via heavy ETL jobs, the data engineers want to write the data. That time how they can write? So same like how we write the data in external Hive table from Spark data frame, that same approach. Okay, so df2.write.option, here we need to provide the path. So maybe in S3 I will go and here I can create another folder, processed data. So here basically suppose this is the folder where the data engineers will put the data after processing it. Okay, and I will go to properties, I will copy this particular S3 URL and I will paste that here. That is basically this is the location where this particular data frame data will be written, and the data will be written as external table, right? So what is the table name? So we'll be putting that. So database name will be same I am as of now putting, and the table name I want to put suppose curated data, like that. Okay, right? Very simple. Now what I will do, I will execute the code. But before that, let me just show you once more that here if I go to tables under this particular database, if I just refresh, nothing is there. Okay, similarly in Athena also, for the data analyst also, as of now only one single table will be displayed, right? Now let's try to write one particular table in our Glue Catalog from Spark data frame. Okay, just hit enter. So it's thrown some error. What is that? No file system SS3. So I think I have written wrong here. SS3 I have written, sorry for that. Here I will just make sure it is S3 and I will hit enter. So basically df2 contain the group by operation outcome. So that we are writing from PySpark to our Glue catalog. And then we will see that this table, which is written by data engineers, whether the marketing analyst or data analyst team can access from Athena or not. Okay. That way both different domains will be merged together like that. Okay. So we have, it is complete. Now if I go to my S3 location first, here if I go to process data, here if I just refresh, here you will see that different Parquet data is written, and here it is success. Okay, right? So that is done. So by default it is writing as Parquet. Cool. And if I go to Glue and even if I refresh this one, here you will see the curated data. Okay, it is pointing to curated data. If I click on this one, here you will see that this is the location. Okay, and here also Glue catalog has captured the column name and data type, that is class name and sum sepal. Whatever our data frame column name was, same it is putting. Class name is string type and sum sepal was double type, right? Now let's go to Athena and see. If I just refresh this one, here you will see instead of one, now we are having two tables. And then if we just try to do curated data limit 5, anyway we know that 3 records only there, but just execute. See, this is what we are getting. Okay, and actually in Spark also we were getting the same. I will just show you side by side. So here you can see ID's versicolor is basically 302.5. That's what is present here. Then ID's Virginica is 329.4. Here you can see ID's Virginica is 329.4 and ID set size 250.3 something. So 250.3 something. Okay. So that means here whatever data present in Glue catalog, both from EMR as well as from Athena, can be accessed, and the data engineers can do long running ETL jobs by accessing the Glue catalog table in EMR, as well as the data analyst or marketing analyst team can access the same table from Athena to run ad hoc queries for analyzing purpose. Okay. So I hope you understood this. The only trick is we have to make this particular in the configuration, and we have to use this particular setting, that is under Glue data catalog setting. We have to select that for Spark table metadata we have to use the Glue data catalog. Okay, and then what will happen, the beauty is, suppose if I am going to EMR and if I try to terminate it, I will just change to termination protection off and I will just terminate the cluster. Okay, so it is terminating. Let's wait for termination. So here you can see our spinned up cluster is terminated, but because our metadata for all these tables are stored in Glue catalog, which is outside our cluster, that's why here you can see that in tables still all the informations will be there. Okay, so the data analyst team or marketing analyst team will have no problem to query the data generated by Spark. That's the beauty of external metadata storage. Okay, right? So I hope you enjoyed this particular session. Try to play with this, try to have some experiment, and you can go through the documentation for details. I will share this in the description box. And if you want to check my previous video where I have explained how you can basically use the Glue catalog for external Hive metastore, then you can also check the video from description section. Okay, this is all for this video. Thank you for watching.